Good morning, everyone. Today's class we are discussed. The last class we are discussed about definition of SAG and factors affecting the SAG. So in this class we are discussing about derivation of SAG and equal levels of points of supports, unequal levels of points of supports with the pressure and ice coating on conductor and plot different problems on SAG calculations. And importance of stringing job. Calculation of SAG. See, the tension is governed by the conductor weight, effects of wind, ice coating, and temperature variations. Now calculate the sag and tension of a conductor when supports are at equal levels, at unequal levels. Here the development of sag equation. Supports are at equal levels. The supports are at equal levels means the poles are in same height. The poles are at equal levels. Then the difference between these two is the length of the conductor should be L. That means here the length of the conductor should be L meters. Here is at lowest point of the conductor is known as sag. Suppose here it is the O is the lowest point of the sag. The length is the length of the conductor should be L by 2. The lowest point should be O, and the lowest point to the conductor supports is L by 2. Each support is L by 2. And the sag at the sag, the weight is always in downwards and the tangential is left side. The length of the span is L meter and the weight of the conductor is W kg per meter. Length of the span is L meter. Weight of the conductor is W kg per meter. And the tension T in kgs, and the lowest point is O. See here it is the supports, two supports, in between there is a sag at lowest point, that is should be O. This the length of the conductor should be in L, it is L by 2, it is L by 2. Right. So here the sag occur at point the curvature OH is almost equal to horizontal. So the distance from O to H is X. Right. At this point the sag will be occurred at W, and the length of this conductor is X by 2, and the weight is W into X. And the y component is opposite component is y. See here is the point O, and the point is H. We are taking only some portion of the conductor. Here OH is the sag at this point. Here it is a X distance. The sag is occurs at X distance. At lowest point is, that is X by 2, and this is Y component is known as Y. Right? Here equal levels of point of supports. Equal level of points of supports. Let us consider a point P, that is OP is here OHR. It is a small curvature. We obviously it is known as line, straight line. If the curvature of OP is very small, so that the curve length equal to its horizontal length and equal to its horizontal projection, equal to its horizontal projection. Here in this horizontal and tangential projection, these two forces acting on portion OP or OH or OP. First one is the tension T acting at O. Here the tension is acting at O point, that is horizontal component. Means here. And the second force is the weight of the conductor. The weight of the conductor OP acting downwards at the length is X by 2. The weight of the conductor at the length is X by 2 from point O. Your vertical distance is Y from P. Assume the distance between OP is almost equal to X, and at sag, that is X by 2, and the weight of the conductor acts as WX acting in downwards, it is X by 2. Here the main 2 points here, the tension T acting at O and the moment of force is about point O, that is equal to, when these two forces are equal, that is T into Y, horizontal vertical component, is equal to WX into what is the length of the conductor is X by 2. Ty is equal to WX into X by 2. From this we are getting Y is equal to WX square by 2 into T. Here the length Y is equal to sag vertical component, and X is equal to, what is X? X is equal to L by 2. X is equal to L by 2. Substituting this, Y is equal to WX square by 2T. Here Y is equal to sag and X is equal to L by 2. Substituting this equation, that is S is equal to W into L by 2 whole square by 2T, that is equal to W into L square by 4 by 2 into T, that is sag is equal to WL square by 8T. Here S is equal to sag and L is equal to length of the conductor, and T is equal to tension. The T is equal to tension on the conductor. Here Y is equal to WX square by 2T meters. that is it supports B, that is x is equal to L by 2 and y is equal to, yes, sag S is equal to W into L square by 2 L by 2 whole square by 2t, that is equal to WL square by 8t. And the supports are unequal of points of supports. The supports are unequal of points of supports. Yeah, the span length is L meters and the unequal supports of length. The span length is L meters. The difference in levels is span length is L meter. Difference in levels is H meter. Distance from support A to lowest point is x1 meters. The distance from B is x2 meters. The tension T is acting as horizontal component. This T in kgs. See here this is the conductor. Here sag is acting on at lowest point is here. A point this is known as O. From O to A is the length is x1 and O to B is the length is x2. The total length is L. Okay. So here it's in vertical component. Sag is at B is S2 and sag is at A is S1. Here two sags will be occurred here. That is sag at sag at point A is S1 and at sag B is S2. In hilly, mainly we are using at unequal levels are at hilly areas. We generally come across conductors suspended between supports at unequal levels as shown in figure. Yeah. Here the length of the conductor is should be L, and this at point O, the at point O, from point O to A the length is x1, from point O to B is x2. The total length will be the conductor is L. Sag at A SC1 is equal to W into x1 square by 8t. So already we are discussing about the same formula. Assuming here an imaginary pole at point C, that means here at point C, that is the imaginary pole, and temporarily omitting the portion after point C, then the A and C levels are supports. And full line. Right, that is what your component is, that is TH is equal to W into length into x2 minus x1 by 2. x2 minus x1 by 2. So that is formula for SAG. That is vertical component, the two forces acting on at point O. What is first one? Vertical component, right? And horizontal component is, that is weight into distance, weight into L into x2 minus x1 by 2. From this we are getting the value of x2 minus x1, that is x2 minus x1 is equal to 2th by WL, 2th by W. Yeah. So we are submitting the same formula here, 2th by WL. Add equations 1 and 2, that is equal to x2 x1 cancel, x1 x1 cancel, 2x2 is equal to, already we know the formula, x1 plus x2 is equal to L, and x2 minus x1 is equal to 2th by WL. Add the equation 1 and 2, that is x1 plus x2, x2 minus x1, x1 x1 cancel, that is x2 minus x2, 2x2 is equal to L plus 2th by WL, 2th by WL. From this we are getting the value of x2 is equal to L by 2 plus th by WL, 2 gets cancelled. And similarly now we are adding the equation 1 and 2. Now we are subtracting the equation 1 and 2. So we get the value of x1, right? So x2 is equal to L by 2 plus th by WL. Substitute in equation 1 we get, that is x1 is equal to L by 2 minus th by WL, L by 2 minus th by WL. So we get the two formulas, that is x2 is equal to L by 2 plus th by WL, x1 is equal to L by 2 minus th by WL. So having found x1, x2, s1 and s2, then h can be calculated. Right. And next, effects of ice and wind pressure on SAG. Here the formula mentioned above for SAG are true only in still air. At normal temperature, the conductor's own having its weight. However, in actual practice, a conductor may have ice coating and simultaneously subjected to wind pressure. Under the above conditions, the weight of ice acts vertically downwards. Weight of ice vertically downwards, and in the same direction the conductor's weight. The wind pressure is assumed acts as horizontally. So wind is always flowing horizontally and the weight is always downwards. So at right angle to the conductor weight, at the total force on the conductor is the vector sum of vertical and horizontal forces as shown in figure. That is, the conductor here, ice coating of the conductor, the thickness of the conductor should be increased. Here, what is the effects of ice is weight increases and weight of the ice is Wi. Weight of the ice is Wi. That is equal to density of ice into volume of ice per unit length. Wi is equal to weight of the ice coating per meter length, and into weight means what, volume of ice per meter length into ice density. Density of ice into volume of ice per meter. Here density of ice is the density of ice into what is the volume. Volume is equal to 5 by 4 d square. Here d is nothing but internal distance, internal diameter plus external diameter and thickness of this diameter. So here it is the internal diameter, this is the thickness, it is a external diameter, thickness is t. So capital D is equal to thickness of the diameter is equal to d plus 2t whole square. Small d is equal to d plus 2t whole square, because thickness is 2 times the two sides of conductor should be same. Right. So here is a conductor, here the thickness, here the thickness, the t and t, here the distance is, diameter is capital D and total diameter is small d. Small d is equal to capital D plus 2t. And ice density that is here d plus 2t whole square means d square plus a plus b whole square, d square plus 2t whole square minus plus 4 into d into t. Here d square gets cancel, 4 gets cancel, that is pi t into d plus t, pi t into d plus t kgs per meter. And the weight of this conductor, that is WC, weight of the conductor is volume of conductor per meter cube into density of conductor material. And weight of this wind, the weight of the wind is always in horizontal position, and that is WW is equal to weight of the wind pressure into projected area. Wind pressure is into d plus 2t, d is d plus 2t into 1. And without ice coating, with ice coating is wind pressure is d into t, that is equal to, here the horizontal component is weight of the conductor and here it is total weight, that is weight of the conductor plus weight of the ice. Here is also weight of the total weight of the conductor, here it is weight of the conductor. The here conductor is total vector sum of vector and vertical and horizontal component, vector sum of horizontal and vertical component. Effects of wind pressure, direction of wind is without ice and with ice. The wind force per unit length is WW, and without ice per unit length is WW is equal to wind pressure into d kgs per meter. With ice is d plus 2t. With ice per unit length, it is equal to wind pressure into d plus 2t. Ice with ice means the external diameter will be increased, that is d plus 2t, thickness of the conductor. That is horizontal component is WW and W plus WI. WC is W plus WI. And the total weight of the conductor should be under root of WC whole square plus WW whole square. WC is nothing but here WC plus WI, weight of the conductor plus weight of the ice. WT is equal to square root of W plus WC whole square plus WW whole square, that is theta is equal to 10 inverse of B by A. B means WW by WC plus WI. Then the sag is W is equal to S is equal to omega L square by 8T. Omega T L square by 8T. Omega T is nothing but square root of W plus WC whole square plus WW whole square. So the vertical component of sag is S into cos theta. Vertical sag is S into cos theta. That is WT L square by 8T into cos theta. Yeah, once again I am explaining the calculation of sag. The tension is governed by the conductor weight, effect of wind, ice coating, and temperature variations. Now calculate the sag and tension of a conductor. When we have to calculate the sag and tension of the conductor when supports are at equal levels and supports are at unequal levels. First case is supports are at equal levels. Equal levels means that is both the poles having same height and the conductor length should be same. And the total length of the conductor should be L. At point O the sag will be occurred. At point O the length is L by 2 and L by 2. And let the length of the span is L meter and weight of the conductor should be W kg per meter. The tension in conductor T, the lowest point of conductor is O. Here at point O it acts as sag. At point P the curvature OP is almost that is equal to horizontal component, that is straight line. So that will be known as at point this sag will be occurred here. So the horizontal component is weight of the conductor, that is Wx, and Y is sag. Here the distance between that OP is x and that is the length of the conductor up to sag, that is x by 2. Equal levels of points of supports. Consider a point P. Consider point P. The distance x meter from O and the vertical distance y is from P. Assume the distance between O P is almost equal to x. OP, that is curvature OP, is almost equal to horizontal component, that is x. And the weight of the conductor is Wx acting in downwards. So always the weight is acting as in downwards, that is x by 2. The tension T acting it. Here the two forces acting on sag, that is one is weight of the conductor and tension. Weight of the conductor is always downwards, that is Wx is acting downwards, that is the length x by 2. The tension T acting at O. The movement of two forces about point O. The movement of two forces, that is about, that is the sag vertical component is, that is T into Y. Vertical component, that is T into Y, is equal to horizontal component is Wx is into L by 2. T into Y is equal to Wx into x by 2. That is T into Y is equal to W into x square by 2T meters. Here at suppose that is B is equal to, at point P the length of the conductor should be x is equal to L by 2 and y is equal to sag. Y is equal to sag. Substitute these values in equation. Y is equal to Wx square by 2T, that is equal to S is equal to W into L by 2 whole square by 2T, that is equal to W into L square by 8T meters. It is the equation for equal supports, that is S is equal to WL square by 80. S is equal to sag and W is equal to weight of the conductor and L is equal to length of the conductor and T is equal to tension acting at point O. When the supports are unequal, that is when the in normal hill areas we are seeing like this, the pole should be different heights, right? So that is at this point the sag will be occurred in two conditions, that is at point x1 and at x2. Here at point the lowest point of the conductor is O. In this O the distance is x1, the remaining distance is x2. The total length is L is equal to x1 plus x2. Here the downwards the weight of the conductor should be in downwards and the tension T acting at point O, that is equal to S is equal to WL square by 2T or 8T, that is 2T means WL square x1 square by 2T. The span length is L meters and the difference in levels is H. H is equal to S2 minus H1. So upper height minus lower height, that is H is equal to S2 minus S1. The distance from supports A, that is x1, to lowest point O is x1 meters and to B is x2. The distance from supports B to lowest point O is x2 meters. The tension T converted in T kgs. Unequal levels of point of supports. When the A and B are unequal, and then at point O, the distance from point OA is x1 and OB is x2. The total length is L. Right? At this point, the sag is accurate vertical point, that is S1, and this sag is accurate point vertical point is S2. That means the previous case we are discussing, we are thinking, we already said that is Y component, that is S1 here and S2 here. At point O, sag at S1, that is WL square by W into x1 square by 2T. Actually this is the formula, that is sag is equal to S1 is equal to WL square by W into x1 square by 2T or 8T. Right? At condition at B, sag at B is S2 is equal to W into x2 square by 2T, x2 square by 2T. Right? But actually the height is h is equal to s2 minus s1. So we get the formula for s2, h is equal to s2 minus s1. So w into x2 square minus 2t minus w into x1 square by 2t. So in this w by 2t is common, that is x2 square minus x1 square, that is x2 square minus x1 square means that is a square minus b square formula, that is a plus b into a minus b. So x2 minus x1 into x2 plus x1. So already we know that formula, x2 plus x1 is equal to the total length of the conductor, that is x2 plus x1 is equal to L. Right? So from the h is equal to w by 2t into x2 minus x1 into L. So in this case, where you see at point O at B, at point O to B, right? So here it is the formula. The tension occurred at T into S2, that is T into Y is equal to, here the distance is, what is the distance is, here it is x2, right? The weight of the conductor should be x2 minus x1, right? So here that is the T that is T into H. T into H is equal to x2 and the distance x2 minus x1 into WL by 2. Same W into L into x by 2. X2 is here, the distance is x2 minus x1. So from this we get the formula x2 minus x1 is equal to 2 into TTH by WL. 2 into TH by WL. So here we get the formula for x2 minus x1. So x2 minus x1 we know, and x2 plus x1 is equal to L. Add the equations. So we get the cancel the x1 term. That is x2 minus x1 is equal to TH by WL. x1 plus x2 is equal to L. So add both of these equations. That is x2 plus x1 plus x2 minus x1 is equal to L plus 2TH by WL. So x1 is 1 gets cancelled. x2 plus x2 is 2x2 is equal to L plus 2TH by WL. So x2, from this we get the value of x2 divided and multiplied by 2. x2 is equal to L by 2 plus TH by WL. L by 2 plus TH by WL. So substitute this formula in equation 1 or 2, we get the value of x1. x1 is equal to L by 2 minus TH by WL. So x1 is equal to L by 2 minus TH by WL. Right, and substitute these values in S1, S2, that is SAG, that is omega S is equal to W into x1 square by 2t and W into x2 square by 2t. x2 is nothing but L by 2 plus TH by WL, and x1 is equal to L by 2 minus TH by WL. So we get the both the SAGs, SAG at A and SAG at B. Next case is effect of wind and effect of ice. First we are studying effect of ice. See here, effect of ice is nothing but the conductor length should be, conductor diameter should be increases. Because of this ice, the conductor should be diameter should be increases. That is, the conductor is like this, inner conductor is like so. Here it is capital D, inner diameter, and outer diameter is small d. So the thickness of the conductor should be T and T. So the total diameter is T, small d is equal to capital D plus 2T. And the weight is increases. The weight of the ice is Wi is equal to kgs per meter. That is Wi is equal to density of ice into volume of ice per unit length. Density of ice into volume of ice per unit length. That is, what is the volume of ice is, that is pi by 4 d square. That is, d means nothing but internal diameter minus outer diameter. That is capital D square minus small d. Capital D is nothing but small d plus 2t. The density of ice is pi t into d plus t. So d is here it is a plus b whole square formula. So separate them and calculate. So we get the only formula, that is pi t into d plus t. That is, total weight of the conductor is Wc is equal to W plus Wi, weight of the conductor plus weight of the ice. Next, effect of wind. So wind is always force in horizontal conditions. The weight of the conductor should be downwards. The weight of the wind should be in horizontal and weight of the conductor should be in downwards. So effect of wind pressure. So the direction of wind pressure is without ice is only horizontal, and with ice is horizontal and downwards. Wind force per unit length, WW kgs per meter is, that is without ice per unit length, WW is equal to wind pressure into D kgs. Without ice means only we are using only wind pressure into diameter. With ice per unit length is wind pressure into D plus 2T, the diameter of the conductor ice, that is D plus 2T into kgs. So with ice is more than the without ice. the wind pressure into d plus 2t. Here the horizontal component is weight of the conductor, weight of the wind, and the vertical component is weight of the conductor plus weight of the ice. That is theta. Theta is equal to tan inverse of b by a. The vector sum of weight of the wind and weight of the conductor. That means total weight. W plus Wi is total weight of the conductor. So that is Wt is total weight of the conductor is equal to Wc plus whole square plus Ww whole square. Weight of the conductor is equal to square root of Wc whole square plus Ww whole square. That is Wt is equal to W plus W whole square plus weight of the conductor, weight of the wind. Weight of the conductor is weight of the conductor plus weight of the ice. Wc is nothing but weight of the conductor plus weight of the ice. Ww is weight of the wind. That is theta is equal to tan inverse of Ww by b by a. That is Ww by W plus Wi. And the slant sag is W is equal to S is equal to omega t L square by 2t or omega t L square by 8t. That is vertical sag is S into cos theta. Vertical means cos theta, horizontal means sin theta. So in this class we are discussed about sag, derivation of sag. First condition is equal, poles are in equal and unequal conditions, and effect of ice and wind, right? So what is the formula? S is equal to W L square by 2t when the poles are in equal length. For unequal length, Wt by L square by 2t, that is Wt x1 square by 2t, W x2 square by 2t. X1 is equal to L by 2 plus Th by Wl. X2 is equal to L by 2 plus Th by Wl. So effect of ice and wind, that is S is equal to Wt whole L square by 2t. Wt is nothing but square root of W plus Wc whole square, weight of the conductor plus weight of the ice whole square plus weight of the wind whole square. So next class we are discussing about problems. So vertical sag is S into cos theta and horizontal component is S into sin theta. Okay, next class we are discussing about problems, different problems on effect of ice and wind and sag, equal point, unequal cases. Okay, thank you.